Alright guys, so we've got a standard split system here, and whenever you start a PM on any system, I always recommend starting with the airflow side first. That way, as you're going through and doing your checks, you already know ahead of time that my airflow is on point. You know, I don't have a dirty filter while I'm trying to take my readings or anything else that's going to skew what you have and then make you have to retake it later on. So to start with that, you know, always start with the filter. From here, you know, just make sure it's not dirty, it's good and clean. Document the filter size for future service PMs, and you know, check the fit. You know, make sure that whatever filter it is actually the correct filter for what you're trying to do. And one of the great things you can do from this point is when you pull the filter out, you can actually look back inside and see the coil from this point. Even if you take your phone, stick your phone in there, take a short video or snap a picture, whatever works for you, you can do that from here. Really easy to access through the filter panel. If you don't have this filter access, you know, sometimes you can find another access panel somewhere else in the system. But this is a really good point to get that picture out. If you look in there and you see a really dirty coil, it's got a lot of build-up, scale, whatever on it, then you immediately know that you need to recommend a cleaning, and at least take that into account whenever you are taking your readings. Next step in our process is we want to verify airflow through the blower. It's good practice to document the blower speed. This particular video, we've got 4 wires here. This purple one is going to be our run wire, and we've got a red, a black, and a blue. So the black is going to be your high speed, blue is your medium, and red your low. So just pay attention to that. You know, that's going to indicate to you what speed's running in what mode. Again, it's just good documentation to have that for in the future. We also want to verify that the blower bearings are good, so you're feeling for side-to-side play and in-and-out play. So as long as you have, if the in-and-out play is very minimal to where you just barely get any movement, it's generally okay. It's maybe an early stage of bearing failure. But if you start getting, you know, a decent amount of travel, I would say, you know, a ½ inch to a full inch or more of travel, depending on your motor, you're definitely having a problem by that point. And especially if you start getting any kind of side-to-side play at all on that motor, you need to immediately write that up as failed bearings, and that motor will need to be replaced because it is on the edge of failure at some point soon. In addition to that, you want to be checking your capacitor. You can do a run test on the capacitor with the motor running. If you're not sure, if it's hard to get to the capacitor. And so you have that as an option. I'll put that formula up on the screen so you can see that. You also, most of the time, if your motor amperage is within range for the FLA, your capacitors are going to be okay, but don't always rely on that. So always try to get in and verify. Other things to look for that you can see here, this system is having a drainage issue, and you can see where the blower housing has some condensation collecting on it right here at the bottom, but it doesn't have it up top here. That is because this blower is actually pulling condensation out of the pan onto the blower housing, and then it's dripping down on the insulation. This insulation is sopping wet, and it's running down into the secondary pan. And so again, that's a whole nother issue. This is a airflow and drain issue that needs to be corrected. Those are the types of things that we can catch just by looking at the airflow side and trying to do our due diligence. Alright, so we've gone through the air side on the filter, the coil, and talking about the blower. Next, we're going to move into the refrigeration side of the system. So it's always important to first identify the metering device. Again, this is another item that is extremely good to document for future reference if it's ever needed. This particular coil is using a fixed bore metering device. It's got a piston inside of a knuckle joint here. The alternative would be a TXV. So this system is going to charge via superheat only. Now we still monitor and pay attention to the subcooling because it does still play a factor, but the parameters of that dramatically change compared to if it was a TXV, right? So with a TXV, we're going to charge by subcooling, but we still pay attention to the superheat. That way, if there's a problem, you could have a TXV and your subcooling be on point, but you could be flooding your compressor back, and that's going to end up killing your compressor, right? So the reverse could be happening to where you have, again, good subcooling, but your superheat is really high. And so that's going to cause a lot of overheating in your compressor and generate a whole nother range of issues down the road. So if you are having some superheat issues with a TXV, always check the sensing bulb mounting. You never want it on if you can avoid it, don't put it on a vertical mounted position. Always try to find a horizontal point to mount it to. No matter what environment it's in, always make sure it's insulated with some sort of insulation tape, whether it be cork tape or the foam tape. It's up to you on what you have available at the time. And it also always needs to have some kind of actual straps on it. If you go up to a TXV bulb that only has zip ties on it, we need to write that up for installing actual straps to strap that bulb down, because zip ties are just not sufficient for the mounting surface. Another thing to look for with a TXV bulb is if the pipe it's mounted to is very dirty, it's got a lot of corrosion on it, it may be having trouble getting good contact with the pipe, and you may need to sand that pipe down to get good clean copper against copper. And the final thing to really pay attention to, and I see this more than you would realize, is it cannot mount on a joint anywhere. You always have to make sure that it's on a nice, flat, even piece of copper pipe. And you want it in the 10 to 2 o'clock position on that pipe. Now granted, if you do a vertical run, 10 to 2 o'clock doesn't really matter a whole lot, but if you're doing a horizontal run, that 10 to 2 is your system standard for where you're going to want that TXV bulb mounted. And that's going to play into your split as well. So the ideal split on any system is going to be 20 degrees. Depending on the system, the fan speed, how it's set up, that could range anywhere from 15 degrees to 25 degrees. That also could depend on your charge. That could depend on how much airflow is being allowed to move. Maybe the registers downstream are closed off too much. So those are the variables we need to look for. And if we start getting outside of that, obviously there's probably some sort of issue. You can have too much split. So really pay attention to that. Also, you want to make sure that you pay attention to the load on the system. So if you've got a really high return or a really low return, that's going to greatly impact the readings that you get. So a high return, if it's 75 to 80 degrees, somewhere in that range, or higher than that, it would be considered a higher return. If the return is, say, 70 degrees or below, that's going to be considered a pretty cool return temperature on the air side to the evaporator. So pay attention to those things. Again, document them. If you've got a really low return or a really high return, those are things that you want to make sure you document when you see them to ensure that there's not some other issue going on. We do have some buildings you'll run into that you'll have a supply bypassing directly back into the return because the registers are too close together. And so the supply is literally pushing out and going right into the return. So the space may be 72 degrees, but you've got a 66 degree return. That's going to cause a lot of superheat issues. That's going to cause a lot of trouble because you're getting too much cold air back and not the actual space air. So next step is we want to take care of the condensate of the system. You'll see this system does have a secondary pan. It is full of water. Again, that goes back to the blower issue we were referring to earlier. But you always want to make sure we clear these lines on every job, especially if we're doing like a annual maintenance inspection. With our system, we do a lot of quarterly inspections. The annual especially, the line should be cleared. And if it is done right, then on the quarterlies, all that should need to be done is just a visual check to make sure that it's still flowing properly and doesn't look like it's stopping up. And then on the next annual, it can be finished or be re-cleared again for that year. This also has a condensate pump. This condensate pump is also extremely critical that it gets cleaned out. You know, the basin is removed, it gets wiped out, it'll get a lot of gunk in there, it'll build up and stop the whole system up. So it's important not only to hit the P-trap of the system, but also do the condensate pump if it has one. Then again, making sure the condensate pump is working, it has power. Many of them will have a safety switch built in, so this system does have a float switch in it, but if it did not have a float switch on the secondary pan, it may have a safety switch built into the condensate pump. So if the condensate pump float internally trips out on a high water, it's not pumping out, then it can shut the system down that way. So under every circumstance, especially on annual inspections, whether our contracts state that we take care of the drain or not, we should always be clearing and cleaning the condensate drain system as much as possible. And some customers will request pan tabs be put into the drain pan. Then if that becomes the case, then we automatically take care of that as well. Those are things we've got to read into and look for inside of our contracts. Alright, so the final step in this process is going through the electrical and the heat. So in this particular case, we've got a contactor controlling the heat strips. We always want to tighten every electrical connection we can find. If we have spades connectors, we want to give a light tug on all the spades we can get to. If we find one that's a little loose or we can easily pull off, pull it and try to recrimp the spade itself. If that doesn't work, then we automatically just need to replace that connection altogether so that we can get a good solid connection as part of that PM. Checking the contactor, you always want to pull that cover off of that contactor and inspect the contacts themselves. If they've got any black, dark ring or anything at all around those contacts, that is indicative of arcing, and arcing is an early sign of contactor failure. If it's just got a little bit of pittedness or slight discoloration, that's usually okay. We want to document it as being pitted, but it's not to the point of failure. So, and then obviously if the contacts look new or barely used, they've got just hardly any wear on them at all, then it's just going to be a good contactor, nothing to worry about. We've got two types of fuse safety in here. So we've got high limits and we have fusible links. They're also known as teardrop limits or fuses. Those are these lower ones down here. These higher ones are your high limits. They're resettable. They will trip and reset. These bottom ones, those fusible links, will not reset. When they trip out, they're done. You have to replace them. We want to go through and typically what I like to do is just isolate each set of coils from each other and ohm across them to make sure that, and ohm the safeties and everything all in series together. That way you can verify that the entire circuit is good right there and everything's like it's supposed to be. I want to urge you to be very careful. If it is a three-phase wiring, many of those three phases have a very different wiring system, and they have a kind of a jumper system, if you will, where they link together at different points. It works. It is very confusing, especially if you're new to it. I've been working on them for several years, and I still have to sit and think about it sometimes. But just be prepared. So this is a three-phase system. It is very simple in its layout and design, but they do get considerably more complicated, especially at the larger systems with higher amperage ratings. Again, you want to tighten all the electrical connections you can get to and you can find. The blower motor here is ran off of relays. You have a sequencer down here that also ties into part of the heat control and the fan control. And inside of your disconnect here, you always want to make sure that you tighten those connections. If you see any kind of burnt wires or any burnt spots or darkness or anything at all, or if you say you hear the contactor or you hear the transformer buzzing, we want to document those types of things and see what we may need to do to fix them. Again, via our program, we do allow you to take 15 minutes or so to go through, do the troubleshooting you need to do. Call me if you have any questions at that point, and let's try to work through it and get it figured out. Lastly, what we want to take care of is we want to make sure all the thermostat wiring is tied in and accurate. If it's a wire nut system like this, just make sure all the wire nuts are still good, nothing's getting rusted. Pulling all the wires, make sure nothing's loose, just pulls out. And just it's a good solid harness, nothing to worry about. If it's on a terminal block where you have actual terminals it's tying into, obviously we just want to make sure that those terminals are good and tight, the wires are making good connection. And a lot of times those terminal blocks will have spades on the back side of that terminal block. You'll always want to check those spades, make sure they're still good and tight, making good connections. At this point, we'd want to take a voltage and amp reading of everything in here. You should have already taken readings on your blower motor. You'll be taking readings on all your heat strips as well, making sure that they're all registering properly, getting good amps. That's going to depend on your voltage and the wattage of your heat strip, whether it's 5K, 3K. They go up to 7Ks. They do have 277 heat strips. You want to pay attention to all those kind of things whenever we're recommending repairs. So say you find a heat strip that's open or burnt, we need to document the kW of the whole system and the voltage it's running at. Is it a 277 volt system? So those are the type of parameters we're looking for. Those are the types of things we want to pay attention to on our motors as well, what the voltage is on them. If you do recommend a motor replacement, we need to know the motor horsepower, the motor amperage, FLA, and the motor speed. We also need to know the motor voltage. So whenever you're going through recommending parts, say you recommend that contactor gets replaced, we need to know the coil voltage of the contactor. We need to know how many poles is on that contactor. This is a 3-pole contactor here. We also need to know how many amps that contactor is rated for. If you recommend a transformer, we need to know what voltage is that transformer rated for. The primary, the input power side, is it a 208 volt? Is it a 480 volt? We also need to know what the secondary side of that transformer is. Is it 24 volts, 120 volts? And the final thing is we need to know what the VA rating is. That's the wattage rating. How many, is it a 70 VA, 40 VA? Those are the readings we need to have ahead of time so that whenever we go to write that up and send to the customer of, hey, you need to fix this part, that's the type of information we need. Again, whenever you're filling this equipment out in the system, it's always great to make notes and put that kind of information in there to where if it's ever needed, we have it. We don't have to question what we have. So the first time you do an inspection on a system and you don't see that type of information in there, feel free to go in and add it to the notes on the equipment itself. That way we've got it for future reference if it's needed. So the very final piece we want to discuss when it comes to an air handler PM like this is you want to make sure that the cabinet itself is sealing properly, that all the doors don't have a bunch of air leaks in them. and so that'll cause a lot of inefficiency. That can cause a lot of trouble with the system, and then you're not moving that air through your coil, or it's coming from somewhere else. You also want to make sure that your supply and return duct are sealed well. You know, we should be carrying mastic tape and foil tape with us both on these jobs. That is a truck stock item, so that we can seal this up, make sure that it has good air tightness. You know, we're not pulling waste air from somewhere else or leakage. So that's going to be the final thing you're going to want to pay attention to at the very end as you're wrapping up that PM, is making sure these panels are tight, they're sealed, everything's on point, and that you're not needing to tape anything up or seal it up. Or if it's a major leak, then obviously we need to be notified of that. Also, that all these screws are good and tight. Nothing's loose. The panel's not going to fall off. You can see that there are a bunch of additional screws in this panel. That is because, you know, the old screws have been wallered out, and so new screws had to be tapped into it. We should again be keeping screws on us. That is a stock item on our vehicles. So when we have screws that are loose or won't cinch up tight, we need to be replacing those. That's another item for skill with your drill, is being able to put these screws in and not strip them out. Having drill control, having trigger control, to where, you know, you can do a controlled speed. You don't need to pull that drill trigger 100% every time. You can just barely pull it and put just enough pressure so that when it bottoms out and hits, it skips your drill bit off of the screw head.
Go ahead.
Alright, so as part of your condenser PM on a split, you want to go through and tighten all the electrical inside your panel here. The disconnect, make sure these wires are snug, they're not burnt, there's no damage, no bugs, no insects, nothing in here that's going to cause any trouble. Next, we will move around to the panel down here. Now this is a three-phase system, but the condenser fan is a single phase. So you'll see a run capacitor for the condenser fan, but the compressor itself has no capacitor because it is a three-phase motor. Now, granted, whether single phase or three-phase, always want to check whatever capacitors are there, and you know, we can do a run test on them. Use the same run formula that we would do on a blower motor, and we can check it with it actually running. That test allows you to see what the actual microfarads output is of that capacitor while in operation. Or you could do just a standing capacitor test, pull it out of the system, take all the wires off of it, put your meter across it and check it that way. Whatever that capacitor tolerance is, that's what we use. If it's 5%, 6%, 10%, whatever that capacitor says you're supposed to be, use that tolerance as to whether or not we replace it. Same thing goes for the contactor. You know, if it's got the same burnt arc look to it, any kind of dark damage, that contactor needs to be replaced and changed out. If you're going to recommend that and the customer doesn't want us to do it while we're on site, then again, we need to know the coil voltage, we need to know the amperage, and how many poles that contactor has. So this is going to be a 24 volt contactor, 3-pole, and it is a 35 amp contactor. All that stated right there on the tag. I know exactly what I'm working with. That's the information we need. On a capacitor, we need the microfarads and we need the rated voltage, whether it's a 370 volt or a 440 volt microfarad capacitor. You know, that does play a heavy role. Another thing we need to check is to make sure that the condenser coil is clean. If it's an annual or a semi-annual, you know, we should be cleaning those coils depending on what the contract states. If it's a quarterly but the coils have gotten dirty again, then we need to write that up and document that, because it's also going to impact our readings as to what we get, whether or not we have a high head pressure or not. Also, we need to pull the condenser fan shroud up and check the bearings on that condenser fan. the same thing applies to it that we would have on a blower motor. We're looking for that in and out play, and we're looking for the side to side. Again, in and out play is indicative of early failure, and then once you get that side to side, you're in a critical failure state on that motor. It could go at any time at that point. So the same applies on the what we need to know. We need to know the fan speed, we need to know the fan voltage, and the fan amperage as well. And in some cases, we may need to know rotation. I didn't mention that earlier, but rotation does play a factor. Not all replacement motors are bi-directional. Some of them only have one direction. So we need to be prepared for that. When you're checking your system pressures, if it is a heat pump system, please always use the true suction tap. It will not be on the suction line. It will be somewhere else on the close to those lines. That way we can always verify that the true suction pull, and that can also help us determine if the reversing valve is having a problem. Also, always try to verify your liquid line dryer split and see if it's more than 3 degrees split on the liquid line dryer. We need to recommend replacement of that dryer and try to find out why the dryer stopped up in the first place. Whenever you go to check your system here, again, you need to know what kind of metering device you're working with. Is it fixed bore? Is it TXV? If we document that kind of stuff as we go through the PMs, then whoever is here checking this condenser in the future can look at that air handler and see what metering device is documented for it, so that they better understand what kind of readings they need to be trying to achieve on that system. That way they don't think they have a TXV and they've got problems because they're seeing readings for a fixed bore. So those are the types of things we need to be looking for, paying attention to anytime we go through these systems. We also need to pay attention to the whips. Make sure the whips are in good condition, that they're nice and tight, they're not corroded, busted open, or coming loose anywhere. Those are the types of things we need to catch. Always need to make sure the panels go back on and that all the screws are tight. Again, if the screws aren't tight, if somebody has stripped them out, then we need to go ahead and use self-tappers and replace those screws and get them back in there so that that's not a problem going forward. I've talked about this several times. Your load is going to affect your system, so keep that in mind whenever you're taking your readings and looking at your superheat, your subcool, and your saturations. You know, your indoor load is going to play a heavy part in that. And so if you're having trouble inside, you're going to see trouble out here as well. One of the things to look for on a lot of split systems is, and this is a perfect example, you should only have one dryer ever in a system, split system like this. This system has a filter dryer installed by the factory internally and a second filter dryer out here installed in the field once this system was put in. That's a huge problem, and if you see multiple dryers in a system, we have to diagnose it, we have to write it up, and that needs to be corrected. Even if we aren't seeing symptoms yet, we will soon, because that system is not going to run very well for very long like that. But don't get confused, a dryer with a muffler. So a filter dryer will always be in the liquid line, or it could be in the suction line, right? But if you see that it looks like a dryer, but it's on the discharge of the compressor coming off of the pipe, that is not going to be a dryer. That is a muffler. Okay, those can fail as well, but they're a little bit more. They tend to stop up, is what they do. So you'll see some different symptoms there because the compressor will constantly load up. You won't see any head pressure, and you'll hear the compressor constantly unloading itself internally on the scroll plates or the high pressure relief built into it because of that clogged up muffler. Again, don't get the muffler and the dryer mixed up, please. When we're going through the electrical, we always need to make sure we check the electrical inside the condenser as well. A lot of times it can get very old, corroded, sun faded, cracked up. You'll see that the condenser fans sometimes grab it and tear it up real bad. So those are things to look out for. Another thing to look for is it is possible to reverse rotation on a single phase motor. Or if it's even three phase, you could see the compressor or the condenser fan motor is spinning backwards. If it's single phase, that means that somebody switched the run and common wires on the system, and that caused a reverse rotation on that motor. Another thing that you could see is if it's three phase, they have two legs switched. So in that particular case, you just need to switch two legs on your incoming power, and that'll fix it on a three-phase system. But again, if it's single phase and you see the condenser fan motor, it's the most common thing to see running backwards. You need to switch those two legs and it will correct rotation and run properly after that. The final thing to pay attention to for this video is going to be your line set. One, it needs to have good insulation. This one, the insulation is getting very old, very busted up, but it's still functional, okay? You could document this insulation as being very worn, but it's not lost its effectiveness, right? So those are things to pay attention to, as well as the line sets themselves. If you see, they've been pinched or bent, or any kind of damage to it at all, we need to document that as well. Those are the types of things we need to catch on inspections to make sure that we're not missing a problem in the system, because any kind of bend or pinching, anything at all, can create restrictions in the system, whether it's on the suction or the liquid line, and it's going to cause a lot of problems down the road that you got to deal with. It's not fun. So just another item to pay attention to make sure you look out for. So with that, I'm going to conclude the split systems PM inspection. These are items that we need to be routinely paying attention to. All the unit data always needs to be inputted. The tags, any extra information that we can fit in there, even if it just gets inputted in the comments and notes of that equipment, that's what we need to be doing. Everybody just keep putting your hard work in out there, and we'll get more videos out explaining how to do more of these systems.